Okay, 6.3, part 2. Today we're going to be looking at the graphs of these exponential functions. Okay, the graphs of these exponential functions can be divided into two parts. Okay, one, and with the base of your exponent, base is greater than 1. There's a greater than symbol. And when the base is between 0 and 1. Okay, so we're going to be looking at those two situations, okay? So first at the base, what I mean by the base is, of course, the base of that exponent. So our standard equation for an exponential is a times b to the x. What I mean by the base is this guy right there. That is the base. Okay, so when that base is greater than 1, for example, 2, 3, 4, 3.5, anything greater than 1, that's going to give us an exponential growth function. That is what we call a growth, meaning it goes up from left to right. The standard look of this function, we're just going to go ahead and we're going to look at the basic look of this function, is it's going to hover really close to the axis right here, and then it's going to spike up and get really big really fast. Okay. This point right here, okay, where it crosses the y-axis, we call that a y-intercept, okay? And that y-intercept is always going to occur at the A. It's going to be the point 0, A. Because if I put in a 0, if x is 0, then this b to the 0, then this b to the 0 becomes 1, so then I have 1 times a, so that just gives me a. Okay, so that y-intercept occurs at that a. So that's always good. Sorry, I'm going to change my there. So that y-intercept occurs there at the a value. And the b comes from what it's growing by. So like this next point here, if this was the point 1, from my y-intercept to here, it would grow by a factor of b, or I'd multiply the output times b. Ends up being a growth function. It's going up from left to right. Okay, and we'll look at kind of how that plays out in a graph, some examples here in a minute. Okay, if your base is less than 1, but greater than 0, like we're not going to go into negative-ish bases, well, we'll look at kind of some and kind of what they look like, but a, again, a times b to the x, but now your base, what I mean by between 0 and 1 is like 1/2, 2/3. Okay, numbers in between 0 and 1, that's going to be what we call a decay problem. Decay, and that basic function then is going to go like this. It's going to go down. And again, though, this point right here is still that y-intercept. It's still going to occur at that a value. And b is then again still what it's going down by, because when I multiply by a fraction less than 1, it causes me to get smaller and smaller and smaller numbers. So that's how it's a decay function. Okay, so we're going to look at graphing these functions. We're going to graph them a lot by point plotting, but we're also going to use a graphing calculator or Desmos to help us out there. To graph in your calculator, again, you go to y equals. So for this first example, graph f of x equals 4 times 2 to the x. We're going to ignore these next directions, so I want you to go ahead and cross those out. That's from a section we skipped in chapter 4, I think. Okay, but we're going to graph this. So the first thing I'm going to do is I'm going to create a table of values for this. So an f of x table. Okay, and I'm going to plug some numbers in. When I put in a 1, that's 4 times to the, we should probably do a 0 first. 0. 4 times 2 to the 0. Well, 2 to the 0 is 1, so that gives me a 4. So I can come over here and I can start graphing these points. I need the point 0, 4. Right there, 0, 4. Plug in a 1. 4 times 2 to the 1. That's 4 times 2. That's 8. I need the point 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, when I put in a 2, 4 times 2 to the second. 2 to the second is 4. 4 times 4 is 16. They've gotten really big. I'm off the graph. Let's go ahead and let's look at some negatives. I can use my calculator to help me with some of those negatives. So I would take 4 times 2 to the -1, and I get 2. So -1, I get 2. Oh, not -2. 2. Okay, so -1, I get 2. Okay, and so basically this graph is going to look like this one right here, because if you notice my base here is 2, which is greater than 1. So it's going to be an exponential growth. So it's going to come up and it's going to grow like that, really steep, really fast. Okay. All right. And so then now, so there's my general graph, which if we look at it on, I actually have this graph in Desmos. There we are. Okay, here it is. Again, it has that 0.04. Okay, and it kind of levels out here. It never goes negative. It just kind of gets really, really close to this 0, this x-axis. It gets really close to 0, but never actually hits it. Okay, so now next we want to describe the domain and range. If we don't remember, domain is your x values. The list of all possible x values. So it's the set of x values. What x's can I put into this function? I like to look at my table. Was I restricted in any way with what numbers I picked over here? Are there any numbers I can't pick? Okay, so if we look, is there any number I can't put in for an exponent? I can put in positives, I can put in negatives, I can put in 0, I can put in fractions. So the domain in this case would be all real numbers, which there are only a small group of functions where you can't put in certain numbers. So normally the domain is all real numbers, okay? So for majority, I'm thinking all of your homework and any of these practice problems, the domain is all real numbers because I can put any number I want into this. Or more so on the graph, this function is gonna keep going to the right. It's going up, but it's gonna keep creeping over to the right for forever, and it's gonna go to the left forever. So it goes left and right forever. There's no like stopping point. But now the range is the set of y values or the set of outputs. Okay, so there are certain numbers that I won't get out over here. There's no possible way for me to take a number to an exponent if everything's positive right here and get out a negative. And if you notice, there's nothing on my graph down here. Everything goes from 0 on up. So my range is y is greater than 0. Because it goes from basically 0 on up. And it never actually hits 0. It gets really, really close, but never hits. So there is my range. Y has to be greater than 0. Okay. Right, so there's a growth function. Okay, next, let's go ahead and look at this next one. Here we have -1/2 to the x. So again, I'm going to create a table of values. So my x, my y, when I put in a 0, I get -1/2 to the 0, which would be -1. Okay. When I plug in a 1, I get -1/2 to the 1, which is -1/2. Okay, so we can go ahead and we can graph these guys over here. So I get the point 0, -1, 1, -1/2. Okay. What about 2? -1/2 to the second. 1/2 to the second is 1/4, -1/4. That gives me -1/4. It's getting me super, super close. It's going to keep getting me super and super close to there. All right, let's go. Let's try negative. Like, what if I try -2? So we can go to my calculator, try -2. -1/2 to the -2. I get -4. -2, down 1, 2, 3, 4. So from that, I can tell in doing my curve, it's going to come up and do something like that. Again, we're going to get rid of this one. Compare the graph to the parent function. So there, we've graphed it. We can also then look at my graphing calculator, and I do have this one graphed right there. There it is. Yeah, my graph was pretty close, just plotting points. Okay, and then describe the domain. Again, the domain is the set of all x's. This graph is going to go to the left and to the right forever, so my x's are all real numbers because I can put any number I want to into here. But now my range, this does not go up and down forever. It doesn't go up past 0 at all. My entire function is down here below the x-axis, so my y's here are negative. Y has to be less than 0 because we're all down there in the negatives. Okay. All right, one last example for this section. So now we want to graph this one slightly more involved, but it's still the exact same process. We're going to go ahead and create a table. If I plug in a 0, 4 times 2 to the 0 minus 3 plus 2. All right, well, calculator might be helpful for that one because I've got 2 to the 0. I've got 2 to the negative 3. So if we go ahead and grab our calculator, so we would take 4 times 2 to the, and then it was 0 minus 3, so that's negative 3. And then, sorry, I lost the rest of it. Plus 2. Yeah, the one bummer with using an iPad is 2.5. So a 0 gives me 2.5. Okay. All right, so a 0 gets me 2.5. Okay. This is not our basic exponent function because if you notice, we've got a lot going on in here. Our basic looks like this guy again. A times b to the x. This has got a lot of extra stuff going on, so some of those previous rules don't really hold. We would expect the y-intercept to be at, what, 4? It's not. It's at 2.5. When I plug in a 0, I got 2.5. 1, 2.5. Okay, so kind of all bets are off here, and this is where I highly encourage you to use your calculator to plug those points in and see what you end up getting. Okay, looking at, I've graphed this, it ends up looking like this. Again, 2.5. You can trace on your calculator to get a few more points. At 2, we get 4. So when I plug in a 2, we get 4, and so forth and so on. And we would just plot quite a few points, but it's going to kind of do a thing like that. This is end up being a growth. Again, describing the domain and range, I can put any number I want into this. So my domain here is still all real numbers. This function, if we go back and look at the nice Desmos graph of it, this function does go left and right for forever. But it doesn't go up and down forever. And so that's where sometimes tracing is nice. We come out and what does it seem to get really close to? It gets close to 2. So this one only goes from 2 on up. Okay, so that would be my range. The range here would be how far up and down does this go? Well, it doesn't go any lower here than 2. So my range is y is greater than 2.